Hello everybody, this is my presentation for week 6 interactive concept for chemistry 2. This week was a little different and I will be explaining the reaction within the nuclear bomb. So first I thought it would be kind of imperative to go through the basics of uranium. So basically U-235 is the form of uranium that is capable of releasing a lot of energy, and so this is an unstable isotope, so when it is bombarded with low energy neutrons it causes the nucleus to split, and the initial fission of the nucleus is then able to generate a chain reaction. U-235 is isolated from U-238, and U-238 is the more common version of uranium that we see, and this is because U-235 weighs very slightly less, so there's about a less than 2% difference in weight, but this gives it the ability to be able to separate from the U-238. And it is somewhat of a difficult and tedious process. When exposed to equal force, the two isotopes will move slightly different speeds, and it makes it possible to isolate them from one another. And one of the first ways we saw this was a diffusion plant, and the first one took up over 40 acres, and this was what was used to enrich the U-235 uranium. So there are a few conditions needed for the nuclear bomb reaction to happen. So for condition 1, high temperature is definitely one of the conditions. You need a temperature of about 100 million Kelvin, and at this temperature hydrogen is not gas but it's plasma. And when hydrogen is in a plasma form, it's in a high energy state of matter and electrons are able to move about freely. And to put this kind of temperature into perspective, it's 6 times hotter than the sun's core, so you can imagine how hot the temperature must be for this reaction to occur. Condition number 2 is high pressure, and what the high pressure does is squeeze the hydrogen atoms together, and the hydrogen atoms must be within 1 times 10 to the negative 15th meters of each other to fuse. And this can be accomplished in several different methods, including magnetic fields, lasers, and ion beams. So the reaction happens in these steps. So first, the atom is bombarded by a neutron to produce an unstable isotope, and this isotope will then undergo fission. And the atom that is bombarded is the U-235 uranium that was separated. And for step 2, the nucleus of the uranium atom is split into 2, and this is the fission process. And in step number 3, the neutrons are released during the fission process, and this initiates the chain reaction of continuous fission. And as you can see on the left, the one atom is bombarded by the neutron, which is shown far most to the left. And as you can see, it splits into 2, and from there on it splits onto 3, and the products of the neutrons can be shown there as well. And the reaction that takes place is an exothermic reaction. So this means that the huge amounts of energy released during this type of reaction, that explains the massive destruction of the nuclear bomb that we are so commonly used to hearing. And that is because the chain reaction just keeps going and going, and it is able to create so much energy when it is released, and that's what we see. Well, that is the end of my presentation, and thank you very much.